So in this problem, which is motion of several particles, we have two boats. We have a boat A that I'm just going to show with a point. This is boat A, and the boat B is behind boat A. And these boats are in a race, and A is leading boat B by 50 meters. So the distance between A and B is 50 meters. And right now, at time 0, the velocity of A is going up. Up is going to be our positive direction. And it's going up at 180 kilometers per hour. And this is equal to 50 meters per second. And B is going up at 180 kilometers per hour, which is 50 meters per second. At time 0, both boats accelerate, and B passes A 8 seconds after 8 seconds. And after 8 seconds, the velocity of A is 225 kilometers per hour. So VA sort of final is 225 kilometers per hour, and this is equal to 62.5 meters per second. And what this is after 8 seconds. So what does it tell us? It tells us that we have a final velocity for A, we have an initial velocity for A, and we have a time. We have a time of 8 seconds that it takes A to go from this initial to final velocity. So we can use this equation, this kinematic equation we know by heart now, and it says the final velocity is equal to an initial velocity plus acceleration times time. And we know all of these pieces of information except for this acceleration. So when we plug in our numbers, we get 62.5 is equal to 50 plus acceleration times the 8 seconds it takes it to go from this initial to final velocity. And we can solve for A, and we get 1.56 meters per second squared. 1.56 meters per second squared. And this is the acceleration of A, right here. Now, the acceleration of B, we know a couple of things. First, we know that both these boats are moving, so they're both moving up this way, and at 8 seconds, B catches A. So B has to be moving faster than A, and B will catch A. So we need to know two things. We need to know that the distance A moves in 8 seconds. So we know B is going to move 50 meters plus whatever distance A moves in 8 seconds. So we can look at another kinematic equation that we have, and we know that the final position is equal to an initial position plus an initial velocity times time plus 1/2 acceleration times time squared. And this is still for boat 1 because we're trying to figure out how far it moved. And if we call this our 0 point, x naught of A is going to be 50 meters. It's 50 meters this way. So x is equal to 50 meters plus its initial velocity, which is 50 meters per second, times 8 seconds, plus 1/2 times the acceleration, which is 1.56 meters per second squared, times the 8 seconds squared. And we get a distance of x is equal to 500 meters. So it means A has moved 500 meters. Now, how far what's the acceleration of B? And I should say this 500 meters is from this origin. So A has really moved 450 meters, right? Because that it starts with extra 50 meters head start. So if we look at B and we want to figure out the acceleration of B, we have this equation again. We know that B has moved 500 meters, its final position, and it started at 0, right? Its final position is up here with A, and it starts at the position down here, which is 0. So 500 equals 0 plus its initial velocity, which is 62.5, times the time it takes, which is 8 seconds, plus 1/2 acceleration times time squared. And we can go ahead and we can solve for A, and we get A is equal to 3.12 meters per second squared.